Okay, so let's do question 3 on a practice test. It says solve homogeneous differential equation. So here's a differential equation here. It's xy squared dx plus x cubed plus y x squared dy equals 0. This is homogeneous because this term is degree 3, this is degree 3, this is degree 3, so all the terms are the same degree, so it would be a homogeneous differential equation. So using theorem 3 then we can make a substitution and this will become separable. So we're going to make the substitution, we're going to let y equal xv, so let's do that. Okay, so again by theorem 3 then, the differential equation will become separable after letting y equal xv. So now let's take derivative on both sides of this with respect to x, so doing that we get then, so we get dy dx equals 1 times v plus x dv dx. I'm using the product rule on this, so thinking the x is the first function and the v as the second function. So derivative of x is 1, so it'll be 1 times v plus first function x times derivative of v, which I'm calling dv dx. Now let's multiply both sides by dx, so doing that we get then, so multiplying everything by dx here, we'll have dy equals v dx plus x dv. Now I'm going to substitute, so in place of dy now I'm going to write this in my differential equation, and in place of y here and here I'm going to write xv. So let's make those substitutions. So doing that we get, okay, so after making those substitutions, so again in place of dy we're going to write this, in place of y we're going to write xv. In this differential equation up here, we get this then. And then let's see, we can rewrite this. Actually, notice here I can pull an x cubed out. Oh, maybe rewrite it actually first. So let me rewrite it here. So rewriting, I have this then, so it'd be x cubed v squared dx plus x cubed plus, that'd be x cubed v times this stuff still. And now let me multiply this guy with this and with that. So doing that we get then, so multiplying things out we get this then. Now I guess I can factor dx out here, but actually notice all the terms here have an x cubed. Let's factor out the x cubed here. So factoring out x cubed we get, okay, so I factored x cubed out here, but I also I pulled a dx out of these guys here, so it'll be a v squared left for that one, a v left for that one, and a v squared left for that one would be all times dx. And here I pull an x cubed out, but there'd be also one x left there, I pulled out in front here. Okay, now let's divide both sides by x cubed. So doing that we get, okay, so dividing both sides by x cubed here and here, and combining the v squared and v squared to give me 2v squared plus v dx plus x times 1 plus v dv equals 0. So this now is separable, we're going to show. So let's take the dv term over here. So I'm out of space, so I'm going to erase a few things and we'll continue. So we get to here then, so I move the dv term across the equal sign, got to here. Now we can separate the variables. Let's divide both sides by minus x and also divide both sides by 2v squared plus v. So doing that, separating the variables, we get, so we get negative dx over x equals 1 plus v over 2v squared plus v dv. So now we're going to integrate both sides. So integrating both sides we get then, so we get this then, so we have to integrate these guys. So the 1 over x will be ln, and so it'll be minus ln of x on this side. Here we're going to make a substitution. So I'm going to let w say equal 2v squared plus v. Let's do that. So w equals 2v squared plus v. So dw dv would then be 4v plus 1. Now we're going to have to, so notice here we don't have 4v plus 1 up here. So we're going to have to rewrite this guy. Let me just show you what I'm going to have to do here. So notice here that v plus 1 is equal to 1 plus 4v minus 3v. And this guy here is the 4v plus 1 over here. So I'm going to make that substitution then in this integral here. So doing that we get then. Okay, so I'm taking my integral of v plus 1 over 2v squared plus v, writing it as integral of 4v plus 1 minus 3v over 2v squared plus v. I'm going to break this up now into two integrals, this part. So doing that we get. So breaking in two integrals, I'll have the 4v plus 1 guy over 2v squared plus v, then the minus 3v guy. I'm going to pull a minus 3 out of the integral, so it'll be v over 2v squared plus v. I pulled a v out, so these v's will actually cross off here. And over here, the 4v plus 1 dv would be my dw. Let's note that here. So my dw is this. So then I can write this guy in terms of w here. So let me do that. So doing that we get. So we get this then. So it'll be integral of dw over w minus 3 integral of 1 over 2v plus 1. And here I'm going to make another substitution. Let's call it, say, u. So let u equal 2v plus 1 here. So I'm going to let u equal 2v plus 1. Then taking derivative on both sides with respect to v, we get then du dv equals 2. And then multiplying both sides by dv, we'll have du equals 2 dv. So du equals 2 dv. Then dividing both sides by 2, we'll have dv equals du over 2. So I'll have this. Okay, and I'm going to make that substitution here then. So I'm out of space, so I'm going to erase some things and we'll continue. So summarizing, we have integral of negative dx over x equals integral dw over w minus 3, integral 1 over u du over 2, where w is 2v squared plus v, u is 2v plus 1. Okay, so now let's start integrating. So the first one, I can pull a minus out, and there's going to be negative ln of x for the first guy here. There's going to be ln of w for this one. I can pull that 1/2 outside here. It's going to become then negative 3/2 ln of u here. So let me write that. So we get this then. So the minus 3/2 here, I can take up as an exponent on the u, and this minus 1 here I can take up as an exponent on the x. Let me do that next. So doing that we get then. So we get this then. And now the ln of w plus ln of u to the negative 3/2. Since you're adding those two ln's, you can multiply the w and the u to the minus 3/2 and write it as a single ln. So doing that we get then. So doing that we get this. And notice here the w up here, I can factor a v out. So become 2v plus 1 there. So now I'll substitute for w and our u here. So making those substitutions we get then. So we get this then. And then I can add the exponents here is like a 1 in that, so it'll be 1 minus negative 3/2. So rewriting we get then. So we get this then, because we have 1 minus 3/2, so it'll be negative 1/2 here. Now let's exponentiate both sides with base e to get rid of the ln's. So doing that we get then. So we get this then, so the e and ln's cancel here and here. So doing that we get then. So we get this then, so, oh sorry, the ln's gone here in this one. So that'd be x to the minus 1 times v times 2 2v plus 1 to the negative 1/2 times e to the c, which I'm going to call c1. And I'm going to bring the c1 over here. So doing that, we get then. So we'll have this. I'm going to call the 1 over c1 c2, just to make for ease of notation here. So I'm going to replace this now with c2. So replacing it, we get c2 here. Okay, so I'm out of space now. So let's erase a few things and I'll continue. So summarizing, we have this now. And recall that y equals x over v. So in particular, we could solve for v in terms of x and y. So dividing both sides by x, then we get v equals y over x now. So we can put the y over x in place of v here and here. So doing that, we get then. So we get this then, making the substitutions for v. So y over x here, y over x here. Let's multiply both sides by x now. So doing that, we get. Okay, so multiplying both sides by x, it would cancel here, be x to the 0, so just be c2 on this side. Multiplying this side by x, the x's would cancel here. Now, let's raise both sides to the minus 2 power. So doing that, we get then. So raising both sides to the minus 2 power. This minus 2 then, we multiplied with that minus 1/2, become 1 there, and minus 2 will be also applied to the y. I'm going to call this guy over here, say c3. So doing that, we get then. Okay, so I call the c2 to minus 2 c3 just for ease of notation, just some constant. Then it's going to be y to the minus 2, and then minus 2 times minus 1/2 is 1, so it's going to be 2y over x plus 1 here. Now let's multiply both sides by y squared. Okay, so doing that, actually, yeah, let's multiply both sides by y squared times x. So doing that, we get then. So multiplying both sides by y squared x. So y squared times y to the minus 2 would just become 1 there. And then x times this guy, x would cancel there, not change that 1 to an x. Multiplying this side by y squared x, like this. Okay, so this would be our solution here, our general solution, where c3 now is just some constant. I guess we could try and solve it for y, but I think it's not going to be easy to solve for y, so I'm going to just leave the answer implicit like this. So this would be our answer right here. So in conclusion then, this guy here is a general solution of our original differential equation. I'll leave it for you to verify if you want to that it is a solution. I'm not going to verify it here. Okay, so we're down to a question. Let's leave the video here.